how do you mathematically measure a path that constantly bends and changes direction? In calculus, finding this exact distance is called calculating arc length. Imagine a car driving along a continuous winding road from point A to point B. If you zoom in close enough on a microscopic fraction of time, the curved path visually straightens out and approximates a perfectly straight line. But since the curve's direction is constantly changing, how do we measure the length of that microscopic segment without laying down a physical ruler? We calculate it using the object's instantaneous speed. The length of that tiny segment is simply the magnitude of the velocity vector, multiplied by that tiny fraction of time. By continuously adding up every single one of these infinitely small speed segments, from the start point to the end point, we calculate the exact total distance. And this continuous addition is exactly what an integral does. So the whole journey from point A to point B is finally solved. And that winding road is perfectly measured by summing its microscopic straight line steps.